Session 9.4 Two Variance or Standard Deviation. These sessions, we are working on the hypothesis testing for two populations of two variance or standard deviation. And we were using the F distribution. We call this as the F test for the hypothesis test with the two variance or standard deviation. Requirement: the two populations are independent and has to be simple random samples. And each of the population must be normally distributed regardless of the sample size. So I don't care about the sample size is greater than 30 or less than 30, but the original population must be normally distributed. Okay, notation. Okay, you can see all this notation. There's a 1 in here, okay? S1, N1, sigma 1. This means all this notation is for the population 1 here. And then the first guy, S squared, that is your sample variance. And for the F distribution, you have to choose the larger of the two sample variance as your population 1. That means when you look at two data of the two populations, first, you're going to look at the sample variance. Which one is going to be the larger one? The larger one will be your population 1. And then another one will be your population 2. Okay, and N, that's a sample size. And this is going to be your population variance. Okay, properties of the F distribution. F distribution is not symmetric. It's going to be skewed to the right, similar to the chi-square. And the values of the F distribution cannot be negative. Okay, the picture is to be look like the chi-square, just like this, skewed to the right, and it is starting from 0. So F distribution cannot be negative. And the shape of the F distribution depends on the two different degrees of freedom. For this distribution, we do have a two different degree of freedom. One is called degree of freedom of numerator. One is a degree of freedom of denominator. Okay, so we're gonna talk about it when we have the table. Okay, procedure for testing hypothesis for two population variance or standard deviation. So first, state the null and alternate hypothesis. Okay, null hypothesis is always equal. Alternate hypothesis can be less than, greater than, or not equal to. But pay attention here. Even though we do have the less than, we're still using the white tail. Okay, greater than is the white tail. And then not equal to, there'll be two tails. So we don't have the left tail test in here. Okay, we could say this is one tail or two tail. And this is the formula for the test statistic. You can see F distribution equal to the sample variance for the population 1 over the sample variance of the population 2. And remind you guys again, okay? The population 1 has to be the larger of the two sample variance. Okay, this one, the numerator has to be the greater than the denominator. And the test statistic never been less than 1. Okay, cannot be less than 1 because the numerator is greater than the denominator, and cannot be negative. Okay, because variance is always positive number. Okay, step 3, find the p-values and interpret the p-values. Okay, so the p-value will be using the calculator. Since this is an F distribution, we'll be using the F, CDF, and then the test statistic 1 in 99, and then the degree of freedom of numerator, common degree of freedom of denominator. Okay, so the degree of freedom of numerator is talking about the population 1, what is the sample size? And then the degree of freedom of denominators, talking about the population 2, what is the degree of freedom? So sample size minus 1. Okay, step 3, find the p-values. and interpret the p-value. We'll be using the calculator for this part. So p-value will be using the F distribution. So you could see that's a F distribution, cumulative area. So you're gonna start with your test statistic, which is you find it from the step 2 here. To the upper value 1E99. And then that will be the degree of freedom of numerator. It's talking about on the numerator here, you will have the sample size. So find the degree of freedom, that will be n minus 1 here. Okay, degree of freedom is going to be n minus 1. And that will be from your numerator. And then comma, that will be the degree of freedom of the denominator. So now the denominator here, for the population 2, find out what is the sample size. And that will be n minus 1. Okay, that will be the degree of freedom. If you have a two-tail, after you find this, you're going to be multiplied by 2. Okay? Or we could use the critical values method. Critical values method will be looking the new table that's called F distribution. And then again, we're going to find out the numerator of degree of freedom and the denominator of the degree of freedom. And last one, you're going to state the conclusion. You'll be using the table from the chapter 8, the 1, 2, 3, 4 conclusion. Okay, so this is how you guys using the calculator to check your work. Okay, let's try to do the example from the workbook, the United States Supreme Court. And that's working on the 2 standard deviation, and we'll be using the critical value method. Okay, I'm gonna work on this paper, but you guys may not see really clearly about the questions here. So I put the PowerPoint in here also. Okay, I want you guys try to read the questions by yourself. Okay, so you can see we have the US Supreme Court, the chief. We do have the first set of the data. Okay, we have the first set of the data here. And then since we have the data instead of the statistic summary, so I'm gonna input this data to my calculator. Okay, so I'm gonna go to the stat. Number 1 added. Let me clean it up this way. So I have a 18, 17, 15, okay, so I have a 16 data here. And then I'm going to go to the statistic, go to the cal, choose number 1, and then I have a second one here. Okay, so I could find out the sample mean, sample standard deviation. And also I have the sample size n equal to 16. Okay, so before we decide which one is gonna be your population 1, which one is gonna be your population 2, I'm gonna write down this information. Okay, so I have n equal to 16. The mean here, that will be 12.75. And then the S, the sample standard deviation, that will be 9197826. Oh, sorry, 9.197826. Okay, try to get more decimal. Get it like 4 to 5 decimal space. And then this is talking about the Supreme Court shift here. And then I have another data because a Supreme Court associate. So this one, they give us the statistics summary. So first, I have a sample size n equal to 93. The sample mean, that will be 16.1720. And then the S here, sample standard deviation, that will be 9.871593. Okay. So remember, for this distribution, you have to choose the larger variance as your population 1. So this is only like the sample standard deviation, right? But remember the S square, you just take square forward. So I'm gonna choose the larger sample standard deviation. So this guy, the second set of the data, that will be my population 1. Okay, so this is gonna be my population 1. Let me write it down here. So this says here, that will be my population 1. Okay, again, because I have the larger sample standard deviation, so I choose this is gonna be your population 1. This guy is gonna be my population 2. And then we are working on test the claim that the US Supreme Court shift had the same variation. So we are working on the variation. So now I'm gonna let the variance, okay? Okay, variance. So I should have the variance here, and I called it like 1 because this is a population 1. That will be the variance of the United States Supreme Court Associate. Okay, and then that will be the population 2. Okay, this is gonna be my population 2. So that would be variance square here, United States Supreme Court, and that will be the chief here. Okay, so here that will be 1 here, 1, 1, and that will be the 2, 2, and the 2. Okay, one more time. You have to choose the larger sample variance or the larger sample standard deviation as your population 1. Okay, so I'm gonna write it down all the data and I compare for it. This has the largest sample standard deviation. So I choose this one as my population 1. This one, that will be my population 2. So this is my first step. Oh, write down the significance level. That is a 5%, which is 0.05. And then the original claim, we want to test the same, do they have the same variation? So my original one, that'll be 1 equal to 2. Okay, set population variance 1 equal to population variance of 2. Okay, the null and alternate hypothesis. So the H0 will be square equal and alternate hypothesis, because they never mention it's gonna be less than or greater than. So we're gonna say that will be not equal to. Okay, step 1, step 2, and the step 3. And since this is a not equal to, you know this is gonna be two-tailed. Okay, and then step 4. So I have the F distribution. Make sure you don't graph it as a normal distribution. Should be like skewed to the right. And then we have two-tailed. Okay, the two-tailed. Okay, and we are working on the critical value method. So that means these two areas here and here, the alpha should be equal to 0.05. Okay, now we want to find the degree of freedom. Okay, find the critical value. So before that, we're going to find the degree of freedom. So we have the degree of freedom of the numerator. Okay, for the numerator. So the population 1 is going to be 92. And then the degree of freedom of the denominator, which is your population 2. So that will be 15. Okay, and then here 0.05 for 2 tails. So you're going to look at the F distribution. Okay, let's look at the F distribution table here. You should have 2 pages. The front page here is talking about significance level is going to be 0.025. Okay, for 0.025. And the other one, that's a significance level is 0.05. Okay, so since we have 2 tails, okay, we have 2 tails, significance level is 0.05, means each tail there will be 0.025. So we're gonna look at this one. Okay, each tail there will be 0.025. And then the degree of freedom for the numerator, that will be on the top. Okay, you can see the degree of freedom numerator, we will have a 92 here. So we don't get exactly the 92, we're gonna get the closest one. So that'll be 120. Okay, you can see this 120 here. And then the degree of freedom for the denominator, you're gonna look at the left hand side here. Degree of freedom of denominator, that will be 15. So that will be this guy here, 15. Okay, so look at it. You should get 2.4611. Okay, 2.4611. That will be my critical value. Okay, so write it down here. I will have the critical value 2.4611. So the 2.4611 is talking about like here. 2.4611. Now we're gonna look at the test statistic. We need to find the test statistic. So here, that will be using the variance 1 over variance, sample variance of 2. So I have the S1, that is a 9.871593 square, because this is a standard deviation, over 9.197826 square. Okay, make sure the numerator should be greater than the denominator. Okay, use the calculator. You should get 1.1519. 1.1519. So 1.1519 on here should be somewhere like here. 1.1519. And we could say the test statistic is gonna be not in the critical region. Okay, this 2 part is the critical region, so this is not in the critical region. Okay, I don't have enough space here, so I'm gonna put it in here. Okay. Test statistic is not in the critical region. So we have a fail to reject. H not. Okay, this one should be like here. And then the final word, the conclusion, we have a not equal to. That's a do not the same with the original claim. And we have failed to reject. So we will be using the number 2 conclusion. Okay, number 2 conclusion. So there is not sufficient evidence to warrant rejection of the claim that, okay, you're gonna copy the claim statement. Okay. So this is how you guys using the critical value method. Okay, the next example, I want you guys try with the question by yourself. And then make sure you write it down which one is going to be your population 1, which one is going to be your population 2. And also final sample size, sample mean, sample standard deviation. Okay, so I have this one. This is a variance more than. So again, this is talking about the variance. So I'm going to let the variance for the population 1. So this is the population 1. And this, well, this one is going to be your population 2. Okay, then write it down, sample size 61, mean -25, sample standard deviation, that will be 16.7. Okay, second one, sample size, the mean, sample standard deviation, that will be 12.4. Okay, one more time. You have to choose the largest sample standard deviation or variance has your population 1. I call this as my population 1 because this guy, sample standard deviation, is greater than the second one. Then significance level, that would be 0.03. Okay, original claim statement. So we have a more than in here. Okay, so I have the variance of the population 1 greater than the variance of the population 2. The null hypothesis, that would be equal. Okay, and the alternate hypothesis, that will be the same as the original one. But we extract more than. And this is gonna be the white tail. Okay, white tail test. Okay. First, find out the test statistic. Okay, so I put the 1 here and 2 here. So S1 16.7 square over 12.4 square. Okay, use the calculator. So you should get 1.8138. Okay, and then sketch the graph here. We have the skew to the right, and then we have the white tail. Okay, so this point here, the test statistic, the F, that'll be 1.8138. And then we need to find out the p-value, the area of the white tail here, that'll be my p-value. Okay, so p-value equal to, this is an F distribution, so we have the F, CDF. First one is going to be your test statistic, comma, to the upper value, which is 1E99. And then the degree of freedom of the numerator. Okay, degree of freedom of numerator, which is 60. Degree of freedom of the denominator, which is 51 here. Okay, calculator. So second box, we're gonna go down to find the FCDF. So test statistic, comma, 1E99, comma, degree of freedom of numerator, degree of freedom of denominator. So we could find the p-value equal to 0.0154. And then we need to draw the conclusion. So we have the p-value here. And we're going to compare with your significance level, which is 0.03. Okay, compare for it. So that would be less than. When we have the less than, we're going to reject the null hypothesis. And then draw the conclusion. So we have alternate hypothesis is going to be greater than. They have the same thing, right? And then we have the reject. So we're going to use number 3 conclusion. Okay, I'm gonna show you guys how to use it with the calculator. So in the calculator, I'm gonna go to the step, go to the test, and then I'm gonna go up. It's gonna be faster. You're gonna see two population, F distribution, hypothesis testing. And then we have the statistics summary. Okay, and be careful, this is gonna be your standard deviation. So the S1 here, that'll be the standard deviation, 16.7, sample size 61. S2, 12.4. Sample size is gonna be 52. And then we have greater than. Okay, greater than for your alternate hypothesis. Okay, calculate. So first, you have the test statistic 1.8138. And then our p-value, that will be 0.01536, which is 154 in here. Okay, and then they state the sample standard deviation for the both populations, and then both sample size here also. Okay, so you could check your work here. Okay, that's it.